Okay, here are some examples of constructing confidence intervals using our formula. Hopefully you'll find these very straightforward and not too crazy. So from a random sample of 32 days, during a recent year, the closing stock price of a company had a sample mean of $41.50. Sigma is known to be 2.42. We're going to construct a 99% confidence interval for mu. So when you see this question, it wants you to construct two different confidence intervals. So what you should do when you read this question, you need to think about, okay, what kind of question is this? Well, not to sound obvious, but it's constructing a confidence interval. And you have a formula for that. So that formula is x bar plus or minus z star times sigma over the square root of n. And now it's just a matter of plugging in the correct numbers. X bar is going to be the same in each case because the sample mean was 41.50 that we're using. Sigma is the same in each case because it's $2.42. And n is 32. The only thing that's going to change is how confident you are, 90 compared to 99%. That's going to change the z star value. For a 90% interval, you're going to want the middle 90% of those sample means. In the 99% confidence, you're going to find the z star value that corresponds to 99% confidence. Okay, so you should be able to do that, and I'm just going to say one more thing before I uncover this. To find the values for 90% confidence level and 99%, remember you can use this table here or use your calculator. We have 90% here, 99% here. You trace the column straight down, all the way down to the z star at the bottom. And we see a 90% is 1.645 and a 99% is 2.576. Okay, the other way is to use the inverse norm on your calculator, which I showed you in a previous video. Okay, so I'm going to uncover these. I suggest you pause the video and work on these, but I'm going to uncover them because it's just plugging and chugging in the values. Okay, so what this interval tells us is that the lower end was 40.796 for the 90% interval, and the upper end was 42.204. And here, I'm going to point out another way to write that interval. Remember that we are trying to estimate what the population mean is. So when we find this interval here, with the parentheses, we're saying that the middle 90% of the data is between 40.796 and 42.204. And what we're trying to estimate is, where's the population mean? So we are 90% confident that this interval contains the mean. So we're 90% confident that the mean for the population mu is between those two numbers. Okay, so this notation is just another way of writing the interval notation. And similar for the 99% interval. The only other thing I'll point out right now is when you look at the numbers, the only difference is the 99% interval uses 2.575 for the z-score and 1.645 for the 90% interval z-score. And that should make sense because if you want to be more confident, meaning have 99% of the data in the middle compared to 90%, you need to go more standard deviations from the mean. You need to go wider. Okay, the second example. Okay, I'll let you read that. And here, notice that we have 22 minutes and 38 seconds. Those are not the same unit. So what I did, I just turned them into minutes. So you can turn 22 minutes, 38 seconds into minutes by saying 22 point what? Well, remember, 38 seconds is 38 sixtieths of a minute. So if you do 38 over 60, it gives you 0.633. And similar for 15 seconds, it gives you a quarter of a minute, 0.25. Okay, so there's your mean and standard deviation. And now you want to estimate the population mean for all runners. So a 95% confidence interval. So you're looking for a z-score that goes with the middle 95%. So again, I'm going to go on, but pause the video and try this, and I'm going to show you the answer. Now I don't tell you how to round this one, so you can be a little bit different than me. You could have rounded at just 22 or 22.01, and then maybe 23.26, but that's really up to you. Okay, so we're 95% confident that this interval contains the population mean for all runners. So we're 95% confident that the mean is between 22.009 minutes and 23.257 minutes. Now part B is a new question for us. Does our confidence interval suggest that the mean time for all runners who regularly run a 5K is less than 24 minutes? So we estimated between about 22 and 23.26 minutes. Does that suggest that the mean for all runners is less than 24 minutes? Well, remember, what the whole purpose here is, we're trying to estimate the population mean for all runners. Our population mean, we're 95% confident that it's between 22 and 23.257. So yes, that interval does support that the population mean is less than 24 because the entire interval lies below 24 minutes. Okay, another way to say that, we're 95% confident that our interval contains the true value of mu. This is evidence that mu is less than 24 minutes. Okay, on the next example, we want to get an estimate of how long CCC students study in a typical week. That is, we want to estimate the population mean study time, mu. So how may we do this? Well, just like we've been doing, the idea of a confidence interval, you take a sample of size n, calculate x bar, then construct a confidence interval using that sample mean. Okay, so here, this one's a little bit different. They tell you that we know sigma is 4.2. A simple random sample of 15 students is taken, and they give you the results. This one is different because we're given a list of numbers. When we're given a list of numbers, and there's only 15 students here, so that's not bigger than 30, and we don't know that the original was normal. So what we have to do here is in part B. We don't know whether the study times are normally distributed because they didn't tell us that. Also note that the sample size is less than 30. So you'd have to check a histogram or stem and leaf plot to check the conditions for this example. And if you vary too greatly from a normal distribution, then you just shouldn't do this. Okay, if it's not too crazy from a normal distribution, so if it's not too skewed or too uniform, then you can do this, except you might want to take your results with a grain of salt. Okay, meaning you don't want to put a lot of stock into your results. Okay, so does the sample vary greatly from a normal? Well, I'll let you in your calculator put your values in list 1, construct a histogram or a stem and leaf plot, and see what it looks like. And you'll see that that'll be slightly right skewed. Not too crazy, but slightly right skewed. So you should take the results lightly. Okay, you're not going to put a lot of stock into your results. But we can still do this process. So in part C, what is the sample mean study time for this sample of 15 students? Well, you calculate the sample mean to be 12. Remember, you've already put your values, all this list into list 1. So if you do stat and then calculate the 1 bar stats, you should get 12 for the sample mean. And now you're going to use that mean to construct a 95 and 99% confidence interval. And remember, we know that sigma is 4.2. So we're going to use that. And this one we're going to round to the nearest hundredth. Okay, so you have everything you need now. Go through and construct those two intervals. And I'm going to show you the answers here. So pause the video if you need to. Okay, so we have our two intervals. Notice that the 99% interval is a little bit wider than the 95% interval because we had to go farther away from the center. We had to go more standard deviations from the center. So does our 95% interval, so only looking at this interval here, does that suggest the mean study time for all CCC students, so that population mean study time, is more than 10 minutes? So we look at our interval, and this interval is telling us that we expect the mean, we're 95% confident that this interval from 9.87 to 14.13 contains the true value of mu. Well, is that more than 10 minutes? Well, this is where you have to be careful. Because isn't 10 minutes in this interval? If 10 minutes is in the interval, then wouldn't it be reasonable to say that the mean is 10? Not greater than 10 or more than 10, but 10? Isn't 9.9 in this interval? Well, 9.9 is not more than 10, is it? No. Okay, so even though we have several values above 10 in the interval, the entire interval is not above 10. So we cannot say that the study time for all students, the mean study time for all students is more than 10 minutes. Okay, so no, because 10 is included in our interval, therefore there's evidence to suggest that mu equals 10 is reasonable. Okay, not more than 10. Okay, more than 10 could be reasonable too, because there's some values more than 10, but there's also the cases of 10 being in the interval and numbers less than 10 being in an interval. So you can't just limit it to more than 10 because that lower bound, 9.87, is not more than 10. Okay.